Welcome all to today's lecture. Myself, Assistant Professor Ms. Tukur Gupta from Ajay Kumar Garg Engineering College, Electronics Department. I am giving lectures on the subject Microprocessor and Microcontroller with the subject code KEC 502, and it is being taught in the 5th semester. So, I am covering Unit 1 in ongoing lectures, and today I will cover the 8085 instruction set. In previous lecture, I covered 8085 data transfer instructions, and today I will cover arithmetic instructions. So, let us move on to the arithmetic instructions. So, arithmetic instructions will cover all the addition and subtraction instructions, and as we will see in the subsequent slides. So, these instructions perform arithmetic operations such as addition, subtraction, increment and decrement. So, under the addition category, any 8-bit number or the contents of register or the contents of memory location can be added to the contents of accumulator. So, by default, one of the operand is always an accumulator. Another can be memory location or any other register. The result, that is the sum, is stored in the accumulator. No two other 8-bit registers can be added directly. Means one of the two operands will be accumulator only. One can be any register, but no two different registers apart from accumulator can be present. Example, the contents of register B cannot be added directly to the contents of register C. Means we cannot write this instruction. This is wrong. Okay. So, let us see what is the format of this instruction. So, this opcode is add. Operand can be R and M. Means R means any register and M means the contents of the memory location pointed to by the HL register pair. So, what will this instruction do? It will add the register or the memory contents to the accumulator. The contents of the register or the memory are added to the contents of accumulator. If the operand is memory location, its address is specified by HL pair and all the flags are modified. So, this is the point to be noted, that all the flags are modified in case of addition instruction. Examples are add B or add M. So, as we can see in add B instruction, one of the operand by default is accumulator. So, what this instruction will do? This instruction will add the contents of accumulator and B register, and it will store the data in store the result, that is the sum of the two contents in the accumulator itself. Again, in this instruction add M, again it will add the contents of the memory location pointed to by the HL register pair with accumulator, and the result will be stored in accumulator. Arithmetic instructions ADC, R, M. Again, in this category arithmetic instructions, next instruction is the ADC, that is addition with carry. Again, the operands are R and M. That is, it will add the register or the memory to the accumulator along with the carry. So, what it will do? It will add accumulator plus any register which is given in the operand or the memory location plus carry, and the result will be stored in accumulator. So, the contents of the register or the memory and the carry flag are added to the contents of accumulator, and the result is stored in accumulator. If the operand is memory location, its address is specified by HL pair. All the flags are modified to reflect the result of addition. Example, ADC B and ADC M. So, what it will do? It will add B to A, again C is also added, and result is stored in accumulator. And in this case, A plus contents of the memory location pointed to by the HL pair plus carry, and the result will be stored in accumulator. So in this way, this ADC instruction is categorized under arithmetic instruction and it will perform the addition along with the carry. Next instruction in this category of arithmetic instructions is ADI. As I have already told you in the previous lecture, that any instruction with the letter I, it denotes that it is categorized under immediate addressing mode, and it will store the data, that's the operand will be given in the form of the immediate data. So what it will do, it will add the immediate value to the accumulator. So the 8-bit data is added to the contents of accumulator, the result is stored in accumulator. All the flags are modified to reflect the result of the addition. What we understand by the flags here? Carry, parity, auxiliary carry, 0, sign. These all are all the flags which we have already studied in the flag register. These all will be modified according to the result. So the example of this instruction is ADI 45H. What it will do? It will add 45 with accumulator with, and the result will be stored in accumulator. So it will add the immediate data given in the instruction. Next instruction is, it will add the immediate data given in the instruction along with the carry. So it will add immediate to the accumulator with carry, means accumulator, immediate data plus carry, and the result will be stored in accumulator. So in this way, accumulator, in this way this instruction will add the contents of accumulator with the immediate data and the carry also. Example, ACI 45H, what it will do? It will add accumulator plus 45 plus carry, and the result will be stored in accumulator. Next instruction is DAD, and that is a double addition. It will add the register pair contents to HL pair. So the 16-bit contents of the register pair mentioned in the operand is added to the contents of HL pair, and the result is stored in HL pair. If the result is larger than 16 bits, then carry is set. No other flags are changed. So what, for example, DAD-B means it will add the contents of BC with HL, and the result will be stored in HL register pair. So if the contents and the result is greater than 16 bits, then carry flag is 1, otherwise the carry is 0. Another instruction in this category is subtraction. So similar to all the instructions which we have studied in the addition, subtraction category is also having the similar instructions. The only difference is it will perform the subtraction. So any 8-bit number or the contents of the register or the contents of memory location can be subtracted from the contents of accumulator. So we have to keep it in mind that the contents mentioned in the operand is subtracted from the accumulator. Don't perform the opposite operation, that the contents of accumulator are not subtracted from the given operand, but the operand value is subtracted from the contents of accumulator. This we have to keep it in mind. The result is stored in the accumulator. Subtraction is performed in 2's complement form. If the result is negative, it is stored in 2's complement form. No other two 8-bit registers can be subtracted directly. So we cannot perform in like this SUB A, comma B, or means no two other registers, means you cannot write SUB C, comma B, means this cannot be performed. Okay. So by default, the one of the operands is accumulator only. So the format of this instruction is SUBRM. It will subtract the register or the memory from the accumulator. Okay. So we can write, for example, SUB B means this instruction will perform A minus B and the result will be stored in A. Next, so here we can see SUBB or SUBM, and again the M denotes the memory location pointed to by the HL register pair. Next instruction in this category is SBBRM. It's similar to the ADC category, ADC instruction. It will perform the subtraction along with the borrow. So the contents of the register or the memory location and the borrow flag are subtracted from the contents of the accumulator, and the result is stored in accumulator. So for example, and all the, yes, we have to note that all the flags are modified to reflect the result of subtraction. Similarly, in the previous instruction also, all the flags are modified. So according to this instruction, the example is SBBB means A minus B minus borrow means carry it, and the result will be stored in accumulator only. Similarly, for this instruction SBBM, A minus memory contents, that is a memory location pointed to by the HL register pair, and also the carry is subtracted and the result is stored in accumulator only. Next instruction is the immediate addressing mode instruction, SUI. So 8-bit immediate data is subtracted from the contents of accumulator. All the flags are modified. For example, SUI 45H. So what it will do? It will subtract the contents given in the instruction, that is A minus 45H, and result is stored in accumulator only. Next instruction is again under the immediate addressing mode, and which can be well understood from this term I letter and present in the instruction. So the operand will be 8-bit data, and it will again all the flags are modified in this instruction, and again the result is stored in accumulator. So by default, for every arithmetic instruction, the result will be stored in accumulator only. So in this instruction, 8-bit data and the borrow flag are subtracted from the contents of accumulator. Means this instruction will subtract A minus 45 H minus borrow, and the result will be stored in accumulator. Next instruction in this category is increment or decrement instruction. So as the term is explaining that increment and decrement operations must be incrementing or decrementing the contents of certain memory location or the register it may be. So the 8-bit contents of a register or memory location can be incremented or decremented by 1. The operand cannot be the immediate data. We have to keep in mind that the operand in this instruction cannot be immediate data. 16-bit contents of a register pair can be incremented or decremented by 1. Increment or decrement can be performed on any register or a memory location. Arithmetic instructions category shows that InrRM, this instruction will perform the increment for register or the memory. So it will increase the contents of register or the memory by 1. So if the operand is a memory location, its address is specified by the contents of HL pair. For example, InrB or InrRM. So what it will do, suppose at certain point of time B is holding 50. Yes, the value of B is 50. So when we are performing this instruction, what it will do? It will increase the value of B by 1. Again, suppose HL register pair is having 20, 30. Yes. So now the contents at the memory location 20, 30, suppose this is X, for example. So when we are executing this instruction, then what will happen? The value stored in 2030 will become X plus 1. So in this way, this instruction will perform the increment of 1 to any operand given in the instruction. Again, next instruction in this category is InxR, that is, it will increase the register pair by 1. So wherever X is present, it means it is denoting something related to the register pair. So we have to understand this. So again, INX means increase the register pair value. Which register pair? Mentioned in the operand. And the result is stored in the same place, obviously. Suppose HL register pair holds 2029. So after executing this instruction, this value will become 20, 30. So in this way, we have to, this instruction increases the value of the register pair by 1. Next instruction is the DCR. Similar to the increment operation, there is on the counterpart there is the decrement operation, again which is performed on the register or the memory location. The contents of the register or the memory location are decremented by 1. So if the operands is the memory location, then it is the address is specified by the register pair contents of HL pair. Yes. So DCRB is an example, or DCRM means DCRB means the register pair, sorry, the contents of the register B will be decremented by 1, and the contents of the register pair, contents of the memory location pointed to by the register pair. Suppose this is the contents of the memory, contents of HL pair. So this we will treat it as a memory location, and the whatever data is stored at this location, it will be decremented by 1. So the result will be stored at the location itself. Next instruction in this category is DCXR. Similar to INX, this is DCX. It will take the register pair as the operand, and the value of the register pair is decremented by 1, and the result is stored in at the same place, DCXH. So the contents of the memory location of the HL pair, register pair will be decremented by 1. So today, under the category of arithmetic instructions, let's summarize what we all studied today. So first of all, there is a basic instruction of addition which will add the accumulator contents with the operands. Next was the ADC that will add the accumulator contents with the operands as well as with the carry. Next instruction, it will add the contents of accumulator with the immediate data present in the operand. ACI, it will add the contents of accumulator. It will add the contents of accumulator with the immediate data and with the carry. DAD, it performs a double addition, that is, it will add the contents of the register pair mentioned in the operand with the HL register pair, and the result is stored in the HL register pair only. Next, subtraction is simple subtraction. It will subtract the contents given in the operands from the accumulator contents. Again, it will in this instruction, it will subtract the contents of the operand along with the carry value, that is the borrow flag, from the accumulator. This instruction will subtract the immediate data from accumulator. This will subtract the immediate data as well as the borrow flag from the accumulator. Finally, increment and decrement operations, it will increase or decrease the value of the given contents in the operands by 1. So, INR and INX are meant for the increment operations and DCR and DCX are meant for the decrement operations. That's all for the category of arithmetic instructions. In the next lecture, we will discuss about the logical instructions and branching instructions. So, that's all for the day. Thank you.